Everyone, my name is Snehal Gawate. I am studying in B.Sc third year Adarsh College Hingoli. My topic is numerical analysis. Numerical analysis is designed to provide mathematical procedure for determining approximate solution of certain problem that arise in science. It provides the theory and application of numerical algorithm which help to determine approximate solution of problem such as evolution of definite integral or solution of nonlinear ordinary differential equation and so on. The first operator is forward differences. Forward differences are denoted by delta. Now let's see how the forward differences are calculated. For that, consider the function y is equal to f of x, where y0, y1, y2, etc. are the values of y. That is, y0 is equal to f of a, y1 is equal to f of a plus h, y2 is equal to f of a plus 2h, where h is the interval of differencing. You can see that if you take the difference of any two consecutive values of y, the interval or the difference will be h. That is, the difference between a plus h and a is h. Likewise, the difference between a plus 2h and a plus h is also h. That means the arguments are at equal intervals. Now look at the forward difference table. The arguments x values are written here. The corresponding entries of x are denoted by y0, y1, y2, y3. Now the difference between the entries, that is the difference between y1 and y0, is denoted by delta y0 and it is called the first forward difference. The first forward difference is generally denoted by delta y, and for each difference these are the values. Means the first forward difference delta y is defined as the first difference will be y1 minus y0 is equal to delta y0. Like that, y2 minus y1 is equal to delta y1, y3 minus y2 is equal to delta y2. So there are the first forward difference. Now the second forward difference are denoted by delta square y. The second forward difference is the differences of the first forward differences. That is, the first value of second difference will be the difference between delta y1 and delta y0. So the difference between delta y1 and delta y0 is equal to delta square y0. Like that, the difference between delta y2 minus delta y1 is equal to delta square y1. So similarly, you can find the next higher order differences. The next differences, that is the third forward differences, generally represented by delta cube y, is the difference between the second differences. So here in this table, the third difference is delta square y1 minus delta square y0 is equal to delta cube y0. We should note that the interval minus y0 is equal to delta y0, that is the lowest suffix, is given along with the difference notation. Y cube y0 is y square y0 minus delta square y1. The lowest suffix of the difference is given. So in this table is called the diagonal forward difference table. Now in this delta y0, delta square y0 and delta cube y0 taken as the leading forward differences. So from the diagonal forward difference table, in this case of forward difference, the leading differences are delta y0, delta square y0 and delta cube y0. These are the leading forward differences. Forward difference operator delta of x can be defined as f of x plus h minus f of x. Second operator is backward difference operator denoted by the notation del. Let's see how it's defined. Consider the function y f is equal to f of x, where h is the interval of differencing. Then the first backward difference of the function is defined as del f of x is equal to f of x minus f of x minus h. Now let's see the difference table. Now x gives us the arguments and f of x gives us the entries. So values of arguments and entries are same as we have seen in the forward table. Now the difference is del f of x is written as here. Also the difference y minus y0 is taken as the first backward differences, but the notation is different. Before In the forward case, y minus y naught was written as delta y naught. Here it will be written as del y, but that is the higher suffix values given with del. So in this case of backward difference table, the difference y1 minus y naught will be represented as del y1. So y2 minus y1 represented as y2 and y3 minus y2 represented as del y3. In this case of second backward differences will be del y2 minus del y1 is equal to del square y2 and del y3 minus del y2 is equal to del square y3. Like that, the third backward difference can also be written as delta square y3 equal to del square y3 minus del square y2. So this is the diagonal backward difference table, and in this case the backward difference table, the leading differences are taken the one at the end, and so leading backward differences are del y3, del square y3 and del cube y3. So in the general we can write del y1, del square y1 and del cube y1, etc. The third operator is shift operator, that is denoted by capital E. Let's consider the function y is equal to f of x. Then the shift of operator E is defined as E of f of x is equal to f of x plus h. The shift operator is also called displacement operator. Displacement operator because it shifts the value of function f of x to the next higher value of f of x plus h. If we find value of f of x, the we get f of x plus h. If we are finding f of x plus h, then we will get f of x plus 2h. That means it shifts the function to the next higher values. Now look at e square f of x is split as e of f of x. Within the bracket e of f of x can be written as f of x plus h. That means e squared f of x is equal to f of x plus 2h. That is when e has the power 2, it displays by 2. That is the meaning. In the general we can write e raised to m f of x is equal to f of x plus nh. E raised to minus m f of x is equal to f of x minus h. So shift operator. Now we learned the three operators. Thank you.